implementation of small wastewater treatment plants in Uruguay, and I'm excited to hear about that because we talked about the linkage between the wastewater and the drinking water systems already, so we're excited to hear a bit about the other side of water.
It works. Well, hi everyone. As she said, TAP Construction has been installing and constructing small wastewater treatment plants across Uruguay. And well, the idea now is to share a bit of our experience and our thoughts about it. So, well, I'll go quick with the system and process. The plants are mainly sequence batch reactors, and well, and we work mainly with two options. One is with more chambers, and another one is with only one chamber, and the process are a bit different, but I cannot deep into this now. So, well, now dive in Uruguay. What happened in Uruguay? Well, we now have already installed more than 160 small units across the country, and if with all the treatment plants, we already have capacity of up to 140,000 cubic meters per year that we can treat. We mainly work with households, as you see, but also with schools. In the households, more than 90% of the plants installed are really small, and they can only treat up to a maximum of 3,000 liters per day. So, are for one house or two houses. We'll talk about specifically about these smaller systems, and as you can see here in this table, their performance varies a lot depending on the unit, and this is a sign that each system works under different conditions. So, well, from there is that we can see three main points that concern us, and those are the maintenance of the units, the users take responsibility on the plants, and also regulation. So, if we think about maintenance, we now have for the smaller units, we don't have a formal contract of maintenance. So we go there and repair the plants once the plants have a failure, because the owners don't see that as necessary, and so they don't want to pay for the contract. Then we have also seen in many cases that the owners have a responsible use within the plants because or they don't care or they are not already informed. And also we don't have in Uruguay a specific regulation for a small system, unlike countries like France or Germany that have a specific regulation for the matter. So now we are working in these two issues, and what we want now to do is we're working now with enhancing more maintenance contract, which will be have to be simple and affordable, so the clients will have them. We will, with those maintenance contract, will generate data, and we will ensure a good performance along many years. So that will be good, and also educate. We see that it's important to educate the user, so we will have more stability in the reactors. Of course, with regulations we cannot infer. Well, so we conclude that these systems have proven to be a good solution for places where there is a lack of sewage network, but we have to work a lot in many aspects, as we say. So now what we're going to do is to in the coming years is to enhance maintenance along the country, and also to collect more data and to educate our customers so they can take also themselves responsibility with the units themselves. Well, thank you all for your attention.
Thank you very much for your concise overview, and I think it's really interesting to also see this part of the whole deal, because otherwise you can do with the rural water supplies whatever you want to if it's contaminated by sanitation. So I'm sure it's helpful information for us, maybe with a more drinking water view as well. Do we have any questions in the audience? Over there.
Hola, buenas tardes. Muy buena la presentación. Me quedó una duda, no sé si me perdí al comienzo, pero quería saber quiénes son hoy los clientes, diría, de estas plantas, ¿no?
Bueno, acá lo puse como más dividido, en el póster lo dejé como más separado porque me pareció que sí era más caro, pero en realidad la mayoría están en chacras y barrios privados, principalmente en el este del país. La mayoría, o lugares como muy alejados en el campo que no tienen acceso a saneamiento, digamos, a una línea. Y después también eso, viste que un porcentaje, eso está como distribuido no en el número de plantas, sino en la capacidad de tratamiento. Y una gran parte también está en escuelas, porque es donde se tienen sistemas más grandes.
Y en términos de población, ¿cuánto más o menos sería esto?
En términos de población total.
Sí, o vivienda.
Hay como unas, capaz que 120 viviendas, 150 viviendas, sí.
Okay. Dale, gracias.
De nada.
Just, I guess it's not easy to understand, to answer this question, but just to get a rough idea of the cost, the CapEx and the OpEx per house, just to get an idea if it's very expensive to install such kind of systems?
Well, I can answer that question as, for example, for a house, what do you mean for a small house, a family house? Well, we can say that for one house with, let's see, up to 10 persons living there, we will say we can have a chamber for $8,000 once, like with key and like finish, and well, and here you have the cost of electricity. That's in Uruguayan pesos. That is the cost per cubic meter according to the cost in energy of Uruguay. But then also for maintenance, you can have once a year you have to remove the sludge. So that's maybe 1,000 pesos or 3,000 pesos, depending where you are. And also depending on the use you have, because the more you use, of course, the more sludge you produce. But those are mainly the main costs of maintenance. And for a maintenance contract, which also include to verify the system as compressors and other part of the treatment units, you will add maybe 800 pesos per mesos. So which, for houses that don't have sewage systems in their house in the street, is cheaper than paying every month to a septic tank. So.
Okay, thank you very much.
You're welcome.
There's one more question up there.
Thanks. Daniel Banchik, thank you for your presentation. It was very interesting. I wanted to add, there are some common types of such containerized or small treatment systems, like MBR or MBBR. So I wanted to ask why SBR configuration was selected.
That's it. Well, we buy the system from a German company, from Claro, and they sell us those systems, and because they in their factory study many systems, and they run tests from different kind of wastewater. So from there they regulate these systems in order to perform better. So we take their experience and their to apply it here. But we also have to, as many people say, is local is also important. So that's why we have to still study in the system how they work in Uruguay.
Don't see any further raised hands at the moment, so is there one?
One question.
Okay,
no.
sorry, yeah.
Thank you.
You already have the mic.
Ustedes dijeron que los desafíos a futuro son los mantenimientos y la colección de datos para generar más información.
Sí.
Uno de los planteos que encontraron en el uso fue el hecho de que puede haber largos periodos sin ingreso de materia. ¿Qué están pensando en ese sentido? Porque creo que tal vez lo que tú dijiste, las chacras turísticas y la zona balnearia sean un ámbito de crecimiento para la empresa.
Bueno, respecto a ese tema, no lo tenemos del todo afinado, pero lo que pasa es que como que el reactor se vuelve como un digestor de lodos. Después que como que vos arrancás con un nivel de lodos, la gente se va, o sea, ya puedes cambiar, digamos, el software para que empiece a airear menos, entonces tenés menos digestión, pero el lodo se empieza a consumir a sí mismo. El tema es que si pasan muchísimo tiempo, si son generalmente no pasa que están 2 meses en enero y después vuelven, pero si pasara eso, en realidad lo que habría que hacer sería volver a inocularlos para que funcionen. Pero por ahora, digamos, el estudio que hemos realizado no podemos decir a verdad bueno, qué es lo que está pasando. Pero eso es un poco lo que hemos visto más que nada. No.
Okay, I don't want to be too fast again, but now I really don't see any hands anymore. So please join me in thanking Lino again for this great overview. And I would like to conclude this session, thank all the presenters again, and I think we've seen the challenges that small systems are facing and that we still have to investigate what these challenges actually are in detail. We've also seen that there are beautiful solutions despite the challenges, including that people don't really want to pay for it, they may not be qualified enough to operate the systems, etc. But I think we've also seen 2 important linkages. One was to climate change and how small systems are particularly vulnerable to that. And another one is we had a connection to schools in the wastewater systems, which is a great group of the clients, as well as in the first presentation, where we also saw that there's a lot of schools affected by the systems with increased arsenic levels. And I think that shows on the one hand that we have a lot of vulnerable people depending on those systems, but schools are also a great entry point to maybe educate the future generations on the importance of water safety and the importance of wastewater safety, and maybe to use this also as an opportunity for education in the field we're all working in. So thanks again a lot for the lively discussions, for the great presentations, and I hand the word over to you. Thank you.
Bettina and Alejandro, thank you very much, the presenters. Now we are going to present Rafael Terra, engineer Rafael Terra. He's going to present Building Resilience in a Changing Climate. He's professor at the Institute of Fluid Mechanics and Environmental Engineering at the University of the Republic. Engineer and climate scientist by formation, Dr. Terra has been working for more than 20 years on climate risk management in the agriculture, water resources, and energy sectors. Doctor in Atmospheric Science, University of California, Los Angeles, USA. Master of Atmospheric Sciences, Institute of Atmospheric Sciences, UCLA, at the USA. Civil Engineer, Hydraulic and Sanitary Option, Faculty of Engineer, University of the Republic in Uruguay. Dr. Terra, the floor is yours.
Thank you so much for the invitation to organize of this meeting. It's a pleasure to be here. I will not be presenting technical data, but sharing some ideas that hopefully will promote discussion. And they asked me to talk about the resilience to climate change. This is already, yes. So there will be a few slides about climate change yet again. That's almost inevitable in any Congress. Then we'll try to describe it, because the question is, what do we do about it? And there's a key distinction of which type of climate variability and change we're confronting that changes the approach required. So I will present two types of situation, which of course is a simplification of reality, and then how is the impact of climate change in type B felt? How do we feel that kind of impact? And we'll get some lessons from 1,000 years ago, and that will hopefully get us to the main objective is, what do we do about it? How do we build resilience? So I start with a paper from 1896 by Svante Arrhenius, which title is On the Influence of Carbonic Acid in the Air Upon the Temperature of the Ground. And the first sentence of the paper I love, which states, a great deal has been written on the influence of the absorption of the atmosphere upon climate. So 128 years ago, they were already complaining about too much talk about the issue. And 128 years later, we're still struggling to address it. So the point being that the root causes and physical mechanisms have been very clear for over 100 years about global warming. Before Arrhenius, the Lawrence and other people described the atmospheric radiative transfer. Arrhenius was the first one that proposed that the increment of CO2 by the Industrial Revolution will eventually warm surface temperature. And to my knowledge, the first quantitative assessment was by the National Academy of Science of the US, I think chaired by Ed Lawrence, which quantified climate sensibility. Climate sensibility is a term that tries to describe what's the increment in surface temperature to a doubling of CO2 regarding the pre-industrial levels. And that was the number, 3 degrees plus minus 1.5 degree. And the latest in the assessment report 6 from IPCC, essentially the same. So not only the physical mechanism root causes are clear, even the quantitative impact of doubling CO2 has been quite stable for the last 40 years. So that's the influence of global mean surface temperature. We've seen this graph many times, but we present 3 or 4 more slides on this issue to raise some properties of climate change that will serve me develop the argument later. First one, it is spatially inhomogeneous, very inhomogeneous. So those are the scenarios. Almost all figures in these 4 or 5 slides are from the latest AR6 report. So these are model scenarios on a 1.5 degree scenario increment of mean surface temperature. On the left, the surface temperature, which is of course higher on ground than on ocean, and it is of course higher on northern high latitudes than almost everywhere else in the world. But everything is of the same sign, or everything is positive. If you go to precipitation, there's positive and negative, there's all over the place, and there's more uncertainty as well. But at small scales, if you go to small scales, the land use changes, local pollution, regional circulation changes, combined with the global signature, and it's much, much harder to assess the attribution problem. Attribution is a jargon that's used to how much of the climate you've been changed is because of global changes and greenhouse gases and what is for other reasons. And of course, predictions become more uncertain at the smaller you go in the scales. Second property of climate change is it manifests itself mainly on extremes. This is observed. This is not scenarios. So this is assessment of self-changing hot extremes. That's the word there in pentagons. So SES is Southeastern South America, that's where we are right now. And the number of dots in each pentagon is the confidence of the human contribution to that tendency of hot extremes. So it's almost everywhere where there's data, there's an increase in hot extremes, and most of these places quite certain that it's human-induced. Same thing for heavy precipitation events. It's harder to assess. It's harder to determine the statistical significance. There's data is harder to analyze, but still there's large parts of the world in which, including ourselves, in which one of the signatures of climate change is the increase of heavy precipitation events. So, again, the question is, how do we address climate change? First, you need to split the situation in two. That's a caricature, but allow me. One, type A climate variability change I call in those situations in which long-term tendencies dominate over internal variability. That's time and some statistic of climate that's relevant to whatever you're dealing with. And I'll give you some examples. So that's from the IAM, which is an institute in Colombia, and from 1960 to a few years back. And the graphs are the area covered by 6 glaciers. So we do have some variability, some turns, but essentially they're monotonically decreasing, which is not surprising because glaciers integrate over time climate. So, and some of those are sources of water to supplies of population. So here the tendency dominates over some small variability that can be seen there. Another one, the graph on the right is the global mean sea level observed or estimated during the last 150 years, which is very in. In impact, that's AOSIS, is the Alliance of Small Island States, and that's a signing of an agreement that they made underwater some years back to give some impact. So if this affects you, it affects those people, then the tendency dominates over, there's internal variability, there's regional variability in sea level change, but there's a dominant tendency, so we are in scenario type A. well, I wanted to complete these examples with an example that we are not so much used to being shown, because they are the winners of climate change, but it's good to see the whole picture. There are also winners. There's two cases, for instance, that's the graph on the right is on the left is the Arctic summer sea ice extent observed as well in the last 50 years, and it's almost as half of what it was in the mid of the past century, and then soon will be gone in some of the summers. So that opens up navigation, oil exploration, and that's a tendency that's very clear, and it's much larger than the variability year to year. And tendencies that's the same graph that I showed before. In temperature in the northern latitudes are very clear. It dominates over variability and opens up new agricultural frontiers. So those are situations, and I recommend this book, Windfall, The Booming Business of Global Warming, by FIng. It's very entertaining and eye-opening. Okay, so if you are in a situation like that, the future scenario is known and will be established in a time horizon that can be estimated. The estimation may have some uncertainty, but we no longer have this source of water for if the glacier is going away. The sea ice extent will be gone during the summers. Situations that may take 10 years, 20 years, 30 years, I may have some uncertainty on that time estimation, but the future scenario is clear. So the natural question, the question that everybody asks, which is what do I have to adapt to? What's the future scenario? You need to tell me the future scenario so I can adapt to the future scenario. It's natural and it's actionable. Planning has to establish and has to be established upon the scenario that you know is coming. That's of course, the predictive paradigm, and NOAA is a most known example of, he knew what's going to happen, he planned for the scenario. So that's, in our mind, especially people with scientific formation like us, we tend to think like that. I need to adapt, well, tell me what I need to adapt to. That doesn't quite work in type B scenario, which is scenarios of climate variability in change in which interannual variability dominates over long-term tendencies. And I can give plenty of examples. I start with this example, which is taken from the INUMET website. INUMET is a weather service in Uruguay. And this is the last 6 months, from February this year to July, past July, and there's a dozen weather stations. And the numbers 1 to 5 tells you in which quintile the monthly precipitation in that station, in that month, fall, historical quintile. So 1 is the lowest quintile, 3 is the mean one, 5 is the highest quintile from a 30-year period of climatology. Then there's the 6. 6 is you broke a record. And the zeros, you broke a record of low precipitation. 6 is you broke the climatological record of highest ever precipitation for that month. So this is the last 3 months, and there's 8, 9 zeros, and I don't know, and a bunch of 6 a couple of months back. So, okay, but you just picked this particular semester was particularly rough in variability. Well, I could have picked last year's semester, which we already know, we have heard in this conference already. We have the highest, the largest and deepest drought that affected the supply of potable water to half of the country. So if I had picked the same graph from last year, it would have been worse. So the apparently natural question comes to mind, what do I need to adapt to? Just doesn't work. Doesn't work. You can do nothing with that question. The focus in the future climate scenario is paralyzing. It's not clear how it looks like or when will it arrive. And in the meantime, we need to survive to extreme events. because in the meantime, you're scared to death that the drought of the last year will come back next year, so you need to build resilience. But not to some God-given scenario like Noah, but to build resilience, and we'll try to show what that means. So the predictive paradigm is not actionable. We need to let go of that. So, and this is part of a very long presentation I used to give in workshops. That's only 4 slides, but I think it's very helpful to understand how do we feel type B climate variability and change. How do we feel in a system? How would you react to that? So this is from another book that I highly recommend, which is Collapse, How Societies Choose to Fail and Succeed, from Jared Diamond, which is a very well-known author, though you probably have read some other books from him. And lessons from 1,000 years ago. This is a church from the Vikings in Greenland. So, history lesson of 1 slide for those, okay. The Vikings got to Greenland in 1984, just before the medieval optimal of temperature in the region. So they flourished coincident with that, and they disappeared, they all died. By the end of the medieval optimum and when the Little Ice Age was coming. So where the climate, living in that area is quite difficult, where the climate variability, vulnerabilities they have, well, it's a list there, we won't go through there, but there was all sorts of limitations in the production, navigation, due to short or cold summers, more ice in the water, etc. So Diamond summarizes 5 factors for the collapse. 3 of them are external. 1 is climate change, but it's not as simple as the climate becomes too cold and they all died. I will go back to this in the next slide. The aggression from other people, the Eskimos, the loss of contact of interest for Europeans in the continent, and internal things that they did themselves, environmental degradation and conservatism. And so what are the lessons I will draw from this example? Climate change operates in the current climatic vulnerabilities and acts synergically with non-climatic vulnerabilities. Such vulnerabilities are exposed during the crisis, always interrelated with other factors: market changes, external aggressions, environmental degradation, population growth, governance problems, leaderships. Adaptability in Syria is a cultural quality, not merely a technological one. That's why part of the reason they couldn't adapt is because of conservatism, and I will go back to that in the last slide. I think there's 2 slides remaining. So, building resilience. 4 bullets. First, let go of the predictive paradigm, which is tough for us with scientific background. There's no point, it's totally hopeless to attempt to predict the timing, duration, depth of the next big drought. Assess current vulnerability in infrastructure, in distribution, and management, and quality, whatever. Assess the culture, especially how climate impacts on those vulnerabilities, the climate dependence on vulnerabilities, and work on all of them. Build adjustable knobs in the system. Early warning of incipient potential crisis. You need to be alert and have knobs to adjust. That's usually captured in drought adaptation plans, which have several degrees of ready, steady, go kind of procedures, but you need to have those things stated and built ahead of time, not when the crisis comes. Timely reaction and communication to event is key to build resilience. All of the above is actionable today, and you need not know the magic scenario of what the climate would look like in 50 years. That's a change of paradigm to a continuous adaptation paradigm. Last slide, because the showing me the time here. So I will finish with two challenges of dealing with the impact of climate change type B. This is not to understate the difficulties of dealing with the impact of type A, which you need to entirely change. It's not a comparison of challenges. It's just to make a point that are different. And I will present two challenges. One related to infrastructure, solutions that are resilient to higher and increasing variability inherently require increased redundancy. This may inappropriately be labeled as overspending or not required. You overdid the design. That's why adaptability and resilience is a cultural quality. You need to convince the citizenry and the politicians that the redundancy is necessary. It happened with the energy transformation to renewable resources in Uruguay. And it was a success, but still to this day I listen people saying, yes, but every now and then you need to pay, you are paying the private generator money that of energy you are not using. But that's part of the redundancy that builds the system. Otherwise, it's impossible to do it. And with water will be the same. It's very high to get money to build new infrastructure when the water is going through the spillway. And regarding soft measures, the challenge regarding soft measures is hard to stay vigilant. It's hard to stay vigilant when it's raining. Same happens to development of irrigation. It's hard to develop irrigation when you have a climate with very high variability and many years you have too much water. Timing of the next crisis is unknown, not even approximately. Regularly assess emerging new vulnerabilities. Stay alert on where the climate vulnerabilities are, and keep drought adaptation plans up to date, and keep everything that you need up to date, and the memory and the discussion and going back to the cultural quality, the education of people and politicians and decision makers that alert and redundancy is necessary to build resilience. Thank you very much. I don't know, whatever you tell me.
Thank you very much for your presentation. Now I'm going to invite Mr. Miguel Doria. Okay. So, any question?
Hello, good afternoon. I would like to make a question. Do you have some assess of the variability of the climate for Uruguay?
There is very many of those done by my group and others, but what's really key is to have an assessment of the impact of the variability on whichever system you are managing. That's the climate variability per se with the variables we usually work with as climatologists don't really translate directly to the risks in the systems. You need to do it purposely on the risk and vulnerability to the system you are managing. Custom made, that's what the word I was looking for and couldn't find.
Any other question? Yes.
Una pregunta breve. Con ese nivel de variación que mostraste hoy, sobre todo, por ejemplo, en el año 2024. Desde lugares con extrema sequía, catalogada con 0 en el calor máximo, y lugares con extremo lluvia, catalogado con 6. ¿Cuáles serían las pautas para dimensionar la infraestructura para atender esa variación extrema y no previsible? Porque cuando uno diseña una estructura civil, generalmente toma parámetros, o sea, toma los 100 años, los 50 años en la pluviometría, o sea, algún tipo de parámetro que sea la referencia para el cálculo del proyecto. ¿Qué ven ustedes en ese sentido, o si hay alguna línea de búsqueda que esté planteada?
Lo primero a decir es lo que dije en la primera respuesta. Lo que importa, la escala temporal de la sequía que importa depende del sistema, porque esa sequía, esos ceros que están ahí no afectó al sistema de agua potable de Montevideo, porque un mes es muy chico para ese sistema, para otro sistema puede no serlo. Entonces, de nuevo, el estadístico climático está adaptado al sistema en cuestión. La infraestructura y esto la gente que ha tratado, que trabaja en el sistema metropolitano lo tiene muy claro, digamos, uno tiene que tratar de convencer de diseñar la infraestructura más resiliente, pero no puede ser la única medida, porque uno va a llegar hasta cierto, ¿verdad? Y puede venir, nadie descarta que venga una sequía que dure un poco más, que sea un poco más profunda. Entonces, pero uno tiene que empujar con este discurso a hacer la infraestructura mayor posible. En particular, el criterio de mínima es que soporte la serie histórica, digamos, ¿no? Claro, si hay vidas en cuestión, como cuando uno diseña una represa grande, entonces los criterios son mucho mayores, es la milenaria, la decamilenaria. Pero después tiene que haber la secuencia de otras medidas de qué voy haciendo, cómo voy moviendo las perillas a medida que voy viendo que estoy entrando en una. Uno tiene que tener perillas disponibles de antemano, que sepa con qué velocidad mover a medida que va pasando etapas.
Thank you very much, Rafael Terra. To Miguel Doria, presenting Water Security and Overview from LAC. Miguel Doria was born in Lisbon, where he studied environmental engineer, worked as a water analyst in a quality control laboratory, as a consultant for hydrological environmental impact assessments. He completed his degree in environmental science and holds a PhD in environmental science from the University of East Anglia, Norwich, UK. He joined the Secretariat of UNESCO International Hydrological Program in Paris in 2006, where, among other duties, he was officer responsible for water education and deputy secretary of the IHP Intergovernmental Council. Since 2015, he is the IHP Regional Hydrologist for Latin America and the Caribbean, based at the UNESCO office in Montevideo. The floor is yours.
Thank you very much. Muchísimas gracias. Eu penso que vou começar em espanhol, pero depois vou cambiar al inglês. Pero empezar por agradecer mucho la invitación. Me fue pedido hoy que hablásemos un poco de lo que la UNESCO está haciendo en materia de agua. Y empiezo por, tal vez, recordar que es mejor como hidrólogo para América Latina y Caribe. Por veces es descrito un poco románticamente como la región que es el paraíso de los hidrólogos, ¿no? Porque, y ahora sí voy a cambiar al inglés, Latin America and the Caribbean is a bit of, or used to be, a bit of the hydrologist paradise, in the sense that we have the largest basin, river basin of the planet here, the Amazon. We have the widest estuary just outside of on the other side of the street, La Plata estuary. We have also the largest or the biggest wetland, Pantanal, We have two of the largest aquifers, Guarani and also on the Amazon. We have 95% of tropical glaciers in the Andes. We also have a series of important lakes like Titicaca or Atitlan, just to mention a few. But we also have the extreme opposite. So the driest non-polar desert is here, the Atacama. And it's a situation that I think, as you could see from the previous presentations, or the previous presentation in particular, is also changing very rapidly over the last 100 years. And not only because of climate change, but of course climate change impacts the frequency and intensity of extreme events. We saw it in terms of precipitation, evaporation, and so on. But also other phenomena like demographic change, land use change, deforestation, just to name a few. So there are lakes in the region that disappeared because of over-extraction, to give an example. So it's a complex time to be in Latin America and the Caribbean when we focus on water. And we've been speaking about water quantity here when we speak of climate change and the recent changes. But of course, it also has a very strong impact on quality and on the topic of this conference, that is safety. But I'll start by focusing on a separate concept that is interrelated with safety, but is very different in a way, even though in Spanish is the same word, seguridad, but in English is completely different concept, and we are speaking about, of course, water security, in the sense that it is often understood as the capacity of a population to safeguard or to access water in the quantity and the quality they need for their uses. And all this taking into account both the environment and also water-related disasters. So, and this done in a, let's say, overall concept of our vision towards the water futures, having, of course, into account the three pillars of sustainability, so the human uses of water, human consumption, that's drinking water, the economic value of water, and just to give an example, we are in a country where a very, very large part of its economy is dependent on water, in the sense that when 1 ton of meat leaves the port of Montevideo, that ton is 80% water at minimum, and it required probably 8,000, 10 times, or 10,000 liters of water to produce a single kilo. And this happens all across the region, in the sense that Latin America and the Caribbean has, or traditionally had, more water per capita than, let's say, the Middle East or Africa. So it's considered a net exporter of virtual water. It exchanges water products or water-rich products by other products that do not require so much water to produce. And this is okay, according to traditional economics, that's the way it should be. We trade things that we have in excess by things that we have in deficit. But in doing so, and now going to the ecosystems, we are also in a region that is considered usually mega rich in terms of biodiversity, but also in a region where the threats to biodiversity have been felt very significantly over the last 100 years at least. Several reports indicate that there may be currently a mega extinction where the freshwater vertebrates are those that are most affected of situations of water quantity, but also because of situations of water quality. And then, water-related hazards, we already mentioned here floods and droughts. Of these, I will focus also on transboundary cooperation in the sense that all the countries in Latin America and one country in the Caribbean have a very significant amount of transboundary waters. And this goes from the Amazonas the Amazon River to the Plata, to the Guarani Aquifer, just to give a few examples. And this, of course, requires a different way of managing water resources. And also good governance, to mention that there is a very urgent and strong need to strengthen water institutions in Latin America and the Caribbean. Well, in terms of access to safe drinking water, I think it's common knowledge that there was a very rapid progress up to 2010, 2015 in terms of ensuring access to drinking water in Latin America. But that progress, in a way, has been stopped, and right now it's more or less stagnated, and this due to a number of reasons. And when it comes to sanitation, the situation is not so good, in the sense that only around 60% of, well, 75% of the region has access to safely manage sanitation, and well, 40% there, it depends on the concept, but there's a very strong difference between rural areas and urban areas. Now, in terms of IHP, that is our program on water, the Intergovernmental Hydrological Program, it has 50 years as a program, 60 years since it started with the Intergovernmental Hydrological Decade in '65. And the main objective is to provide and ensure a water-secure world where people and institutions have adequate capacities and science-based knowledge to make informed decisions on water management and governance. And the way we do this is by, well, on one hand, taking into account all the hydrological principles that guided IHP since its beginning, but also taking into account social factors, economical factors, and cultural factors. And we are organized into phases. Right now we are on our 9th phase that is designed by member states. So member states decide what we do. And is focused on 5 priority areas. First one on research and innovation, knowing the importance of knowledge to address, and of innovation, of course, to address the water challenges. And here just to mention that it also includes, in a way, the water cultures. We are also in a region that is extremely rich in terms of ancestral cultures, and many of those cultures are being lost. So maybe as an emphasis here, or as a parenthesis here, also to include the traditional water technologies of the region that are also being threatened, well, in this case, mostly by urbanization. So many of the rural water systems are being abandoned or neglected because no one knows how to care about them anymore. So water research and innovation, water education in the context of the 4th Industrial Revolution, bridging the data and knowledge gaps, integrated water resources management under conditions of global change, and water governance based on science for mitigation, adaptation, and resilience. And all these, well, in an interconnected way, knowing that the priority area 2, water education in particular, has been transversal for IHP since its beginning. One of the things we do is to bring together all the water directors of the region every 2 years to focus on priorities and collaboration among different areas, including on research. We have 6 water-related centers. I'll mention just 3, so 2 here in Uruguay. One that is relatively new, which is CERTS, focusing on experimental sanitation technologies, and one that has already a number of years and is being, let's say, a leading institution on different areas, including a project we have for the Guarani that is Ceregas, which is the Regional Center for Groundwater Management for Latin America and the Caribbean. Other center I'll mention, because of the relevance for this event today, is CERCI, which is the Regional Center for Water Security in Mexico. And these centers, along with the UNESCO chairs on water, they form what we call the UNESCO water family. Here in Uruguay, we have at this university, UdelaR, UNESCO chair focusing on water and culture. That is headed by Professor Javier Tax. And they focus on a wide range of issues, from urban waters to water and gender, tropical freshwater management, membranes, and so on and so forth. And we operate along a network of working groups that focus both on thematic and geographic topics. It's overall, directly or indirectly, is a network of over or around 500 experts. In terms of, I'll go into detail into some of these groups in a few minutes, but just to mention very briefly that it ranges from snow and ice, and focusing largely on glaciers, but also on Antarctica water sciences. Hydrica, that is for the Amazon geomorphology. Plata Basin, that is for, of course, the Plata River Basin, where the countries have done studies on things like the governance, but also a platform to use satellite data with the French CNES agency, that is a center of aerospatial studies. So satellite data to assess a number of water quality parameters on the basin, such, well, obvious ones like temperature, but also sediments and chlorophyll, just to give a few examples. So that's Cuenca del Plata working group. Friend Amigo, that focusing on flows, and they have been working a lot on maxima, hydrological maxima. ILAC on sediments, ILAC on floods, ISARM America on transboundary aquifers, GWADI on arid zones and droughts. Urban waters, that is an obvious one. Hydrological, and just to mention that we are on the most urbanized region in the planet, over 80%, I think now over 85% of the population are based in cities, including several mega cities with more than 10 million people, like Rio de Janeiro, Buenos Aires, São Paulo, Mexico City, and several other cities, I think Bogota and Lima. If they are not there yet, they will be reaching it very soon. The hydrology of forest systems, eco-hydrology, water education and cultures, graphic that is focused on the use of groundwater under emergency situations. It's particularly active in the Caribbean due to the impact of hurricanes on water infrastructure. And there's also a working group focusing on the Caribbean. Maybe just to invite you, because I will not mention it again, invite you to have a look at the eco-hydrology working group work, in the sense that it's fairly useful in terms of improving water quality, and there are a number of demonstration sites in the region that have demonstrated so. Now, I would like just to mention 2 or 3 of these groups. One is the International Sediment Initiative that met in Costa Rica, I think 2 weeks ago in a conference. But I mentioned this because sedimentation is erosion and sedimentation are processes that are often forgotten and have an enormous impact, including when it comes to water treatment and water safety. And I think it's easy to see outside the amount of sediment of La Plata Basin. It comes from the Andes, actually, via Bolivia. There are in Bermejo, Ipicomayo rivers. Some of them, during parts of the year, they are more mud than a river, but anyway. But across the region, it's very evident the impact of sedimentation are having and the economic cost. Also, when it comes to navigation, generation of hydropower, among other things. So it's one of the areas I would like to invite you to have a look. Another one was already mentioned here before. It has to do with the situation of glaciers. All the mass of glaciers is being reduced very fast in the region. Over 60 million people depend on it directly or indirectly, and also it has a key importance for the Andean ecosystems. So it's another working group I would like to mention in detail. And there's also, in this case, a subgroup of GWADI, so focusing on droughts and arid zones that has to do with the importance of community organizations for water and sanitation services. So they are called OXAs. They are particularly active in countries like Chile, Peru, parts of Ecuador, and these mostly in rural areas. So it's also here a management model, but they tend to do a great use also of small water treatment and distribution systems. And also I mentioned at the beginning, just say that, and this is an example of other areas, but related also with safety in a way, much more with security. But the importance of emerging areas like cybersecurity for water security. And this is obvious, well, in a year where several water plants in the region have stopped their operation due to hacking. And this done with for the university. We have a series of publications that are available on the web, also a scientific journal. It's not been easy. I mentioned the issue of water sciences in Latin America and the Caribbean. We are in the region that has the smallest amount of patents on water technologies in the world. I think it's in the same number as well, other South regions. And in terms of scientific publications, it's been also, there's a very small number of regional publications. There's LAC, Ribagua, and I think 2 more. But in terms of citations, all of them are struggling. So I'm inviting you to have a look about them, consider publishing. Voy a cambiar a español, ¿no? Que invitarles a considerar publicar en español para tener en cuenta también la necesidad de publicar y fortalecer los medios de difusión científicos en español. Y bien, muchísimas gracias por vuestra atención.
Any question? No questions at all?
Hola Miguel, muchas gracias por la presentación. Pues me interesa muchísimo el tema porque yo estoy trabajando seguridad hídrica, pero en el caso en la Amazonia, y te quería preguntar precisamente sobre eso porque en los mapas de trabajo, inclusive los grupos donde se están realizando, creo pues no se ve que se haya, digamos, trabajado mucho en la región y algunos enfoques en la Amazonía. No sé, ¿me corriges o qué planes han hecho o tienen a futuro a trabajar? Y lo otro es lo relacionado con comunidades étnicas, comunidades indígenas, si han podido trabajar ese tema, el tema del conocimiento tradicional y el conocimiento indígena precisamente en la seguridad hídrica. Gracias.
Sí, muchas gracias. Bueno, a lo que respecta a la Amazonia, hay este grupo hídrica, está coordinado por el CENAMI y se reúne frecuentemente, pero el enfoque que están teniendo es precisamente en la variabilidad hidrológica de la región. Y en paralelo trabajamos mucho también con la OTCA, que es la Organización de Tratado de Cooperación Amazónica. Ellos están desarrollando un observatorio que incluye varios de estos datos y se considera también la inclusión de datos satelitales para la observación de la calidad del agua. Y en lo que respecta a los conocimientos indígenas, sí, nosotros hace un año que hicimos un simposio de varios días sobre el tema. Tenemos una publicación que pienso va a salir este año, está prácticamente lista. Y actualmente estamos iniciando, y acabo de mencionar también de nuevo, que la cátedra de la UdelaR de Agricultura está muy involucrada en esto, pero estamos iniciando este año también un inventario de hidrotecnologías ancestrales, en el sentido que hay mucha cosa, pero nadie la conoce, no está bien documentada, y es un conocimiento que, o sea, no hay un conocimiento científico y que no se puede perder, porque realmente hay una amenaza grande también a que se pierde eso con, bueno, hablé acá la urbanización, o sea, con las personas van de su pueblo a la ciudad, se queda ahí algo que se pierde, ¿no? Pero sí, estamos trabajando en la difusión y el conocimiento de estos conocimientos. Y además de eso, también en proyectos como el guaraní que coordinamos ahora, estamos organizando encuentros de pueblos indígenas para discutir su involucramiento en la forma como los recursos hídricos son manejados a nivel local y bueno, en el caso de guaraní, también cooperación con los otros países.
Any other question? Well, thank you very much, Mr. Doria. And now